Potential difference applied. Actually, I should write ratio of, wait. A ratio of potential difference applied to current flowing. Yes, Devish, you want to say anything? Flowing through it is constant. Okay. The ratio of the potential difference applied to the current flowing through the circuit is constant when temperature is constant. Now, yes, so you can say V by I is constant, and it depends upon that constant is what? It depends upon whatever is the resistance that is applied. Then while writing the statement, definitely you can write this thing in the form of equation, Ohm's law, whenever will be asked to you. Might be 1 or 2 marks question can be, and this can be. Now, simple, not a very great thing we learned, right? You know all these things already. Now, based on this, yes, now we want to solve the numerical. And for that, series parallel combination we are talking about. And whenever the resistances will be in series, voltage division rule can be applied. And whenever the resistances will be in parallel, then current division rule can be applied. So, you know when to, instead of saying, just saying I'll write it, that is better. So when you used to say yes, resistances are in series, कब बोलोगे these two, let us say these two resistances are in series, when you are going to say? Yes, bolo division 2. आप कब बोलोगे two resistances are connected in series?
Current is same.
Current is same, but once I think in your division, current is from your division or division 3 or 4?
Division 3.
3, okay. So what he said, in a circuit, you may have n number of resistances. Let us say I'm just trying to draw. And you may find 1 ampere over here and 1 ampere in this circuit. Okay. Then can you say these two resistances are in series? No. Right? So one more thing is, end point of first one should be connected to the second starting point of the second one. But even if I'll have, but even if I'll have this combination, very well I can say end point of first one is connected to the starting point of the second one. So what is the main thing? Yes, how you should define the series resistances then? आपको समझ में आ रहा है what I'm trying to say? Yes. Yes or no?
Yes, ma'am.
So what I'm missing here, what I should add one more thing in the, when we are talking about series resistances, what is one more thing you should add? One thing is their current should be same, right? Second, current should be same as this condition. Then second thing is, yes, you can, the end point of first one should be the starting point of second one. So these two things should be shorted. Third very important thing is there should not be branching of the current. Have you understood? Yes. No branching. Yeah, good. So I'll write all these points. First is current should be same.
बट मैम ये तो ऑब्वियस है ना, अगर हम ब्रांचिंग होगी तो हम करंट डिफरेंट हो जाएगा.
Correct, right? No. If you will say just endpoint of first one is, अच्छा ये दो condition आप एक साथ पकड़ो तो, right? Yeah, correct. Of course. So I'm not going to write that third point. I just explained that thing. Current in them should be same. And endpoint of first connected to the starting point of second. Okay. Just remember, why I'm putting all, no one will ask you these things, why I'm putting in this particular format or writing all these things, because I've seen student used to consider R1 and R2 in series. I've seen this and I'm 100% guaranteed आपकी क्लास में 5 तो ऐसे होंगे जो ये अप्लाई करेंगे. That's why again and again the same thing I'm repeating. Nothing, no any other intention. Okay. Okay, fine. Chalo, so let us draw the diagram. Acha, we'll draw vertically. Will be easy to explain the voltage division rule also on the same time with the same diagram. So let us say two resistances connected in series and the potential V is applied to the combination. Current through them will be same because they are in series. So let us name it I. Voltage, let us say total applied is V. First resistance R1, second resistance R2. Let us say the potential across R1 is V1 and potential across R2 is V2. Okay. Now what you want to do is you want to know, one is voltage division rule. First we'll write the equivalent of this, which we many a times we have written, right? So, pata nahi, IMU के अंदर this thing also can be asked in the paper. So it's best कि we'll write each and everything. So one thing is, let us say the equivalence of this. Okay, both the or whatever n number of resistances which are connected in series, we'll name them as R equivalent. So if we'll talk about R equivalent, you can say I is equal to, or I'll write it as V is equal to I into R equivalent. Okay, if I'm talking about V1, then I can say I into R1 as the potential. If I'm talking about V2, yes, I'll say I into R2 as the potential, right? So we know, just we can see here, V1 when you are saying, it is the potential between these two terminals. And when we are saying V2, it is the potential between these two terminals. So if you are saying total V, you can see this is same potential. V is equal to V1 plus V2. So you can put it as R into R equivalent into I, R1 into I, and R2 into I. So I is common. Yes, very well. You can write it as R equivalent is equal to R1 plus R2. So you know, whenever the resistances are in series, you are supposed to add their resistances, resistance values. That's it. Now, voltage division rule means what? When you are having n number, this is applicable only for series resistances, one thing. Second thing is, whenever you'll find n number of resistances connected in series, right? And you want to find out drop across any one of them, right? Applying that formula immediately without calculating the current, you will be able to get the value of this resistance. So yes, by calculating the current and then calculating the drop, that is also possible, but that will consume time. So we are now talking about some shortcuts with which it will be easy for us to, easy and fast it will be for us to get the drop across the resistances. That's it. So I'm talking about voltage division rule. And And let us think of this circuit only. Instead of making it complicated, first we'll talk about only two resistances connected in series, right? And we'll talk about only V1, let us say. What will be the value of V1 for in terms of the voltage applied and the resistances that you are having? And we know, yes, current is going to be the same. Current ka formula we are having, from this I can write it as V upon R equivalent. R equivalent is I, right? And the same thing I can write for this R1 also. The same I is passing through it. It can be written as V1 upon R. So now we know the R equivalent, that is R1 plus R2 is equal to V1 upon R1. So now if I want to know the potential across any of the resistance, right, let us say R1, the formula is that particular resistance divided by whole branch resistance multiplied by the total potential applied. Right? Again, I'll repeat. If you want to know voltage across any particular resistance, that is equal to that particular resistance divided by whole branch resistance multiplied by total potential applied. Can anyone tell me what will be V2? Yes?
R2 upon में R1 plus R2 into V.
R2 upon R1 plus R2 into V. Very simple, है ना? And now if you are having three resistances connected, 0, V, R1, R2, R3, and this is your V2, let us say. You want to calculate V2. चलो फटाक से बोल दो formula. For this, yes.
R2 upon R1 plus R2
plus R3
into V. Okay, good enough. Now I'm talking about this potential. I'm naming it as V dash. V dash will be equal to, it is in between these two terminals. Yes.
R1 plus R2 ऊपर आ जाएगा.
बस R1 plus R2 ऊपर आएगा, डिनोमिनेटर में R1 plus R2 plus R2. Very correct. Very simple for series resistances, है ना? Now, yes, can I clear the board?
Yes, ma'am.
Yeah.
Wait.
Wait. Okay, I'll wait. As soon as I'll finish, you just tell me, huh?
Done, ma'am.
Done. Okay. Sure. So now the next is current division rule when your component, I mean the resistances are connected in parallel. So let us first go for parallel resistances. Yes. I'll draw a combination of two resistances connected in parallel. So okay, fine. So V, I, R1, R2, let us say I1 and I2. Correct? So the resistances are in parallel. We are supposed to, we want to know the potential. First thing is the potential drop will be same. So V is equal to V1 is equal to V2 you are going to have. Right? So very well you can write I1 R1 is equal to I2 R2. Right? Now when you are talking about the current, I is equal to I1 plus I2, because you can see entering current is I and the division is I1 plus I2. Now if I am saying this combination is, the resistance combination is R equivalent, let me mark it, right, as R equivalent. Then for I you can say V upon R equivalent. I1 के लिए you can say V upon R1 and plus V upon R2. So V is common, cancel it out, right? So you can have 1 upon R equivalent is equal to is equal to 1 upon R1 plus 1 upon R2. So whatever n number you are having in parallel, you just keep on adding. And in short, if you are talking about two parallel resistances, very well you can write R equivalent is equal to multiplication in the denominator, तो ऊपर जाएगा. So R1 into R2 divided by R1 plus R2. एक minute. Yeah. So now I am talking about, किसी को कुछ doubt नहीं है इसमें, I know you did this thing many a times. Now the main thing is, which you are not aware of, that is the current division rule. So let us go for it. Okay. Same diagram, and we'll apply the current. Now current division rule mean n number of resistances connected in parallel with each other, right? You are not calculating the individual current or voltage which is there, right, which is applied. You know the current supply, right? Individual voltages also you are not, or the current that you are, the total voltage that is applied also you are not aware of, and but you know the current applied is you know that, and using that can we get the individual currents in that particular any of the register which you want, right? Let us say we want to know I1, okay, in this particular case. So yeah, now what we know, yes, I is equal to I1 plus I2. Okay, so for I2 what I can write? For I2 I can write I minus I1. Now because the resistances are in parallel, you are writing I1 R1 is equal to I2 R2. So I2 का वैल्यू डाल देते हैं. I1 R1 is equal to I minus I1 into R2. Right, open the bracket. I1 R1 is equal to I R2 minus I1 R2. So I1 common है, shift this term on this side and take I1 common. I1 is equal to R1 plus R2 into I. So how I can write the current in a particular branch without calculating any of the voltages is I1 is equal to the current that you want to calculate in a particular resistance will be equal to resistance in the another branch which is parallel to it, R2. Okay, divided by the addition of the parallel resistances R1 plus R2 and multiplied by the total current entry. Is it okay, everyone? Yes?
Yes, ma'am.
Yeah, can you tell me I2?
R1 upon R1 plus R2 into I.
R1 upon R1 plus R2 into I. तो simple है for two resistances, right? Now let us say you are having three resistances connected in parallel. I'm not going to solve. I want you to go for. So three resistances connected in parallel. R1, R2, R3. And solve मतलब I don't solve it. No, I don't want you to solve like मैंने solve करके दिखा है. I want you to apply the formula. जो formula मैंने बोला है. Current in the particular resistance will be the resistance parallel with it in the another branch divided by addition of the parallel resistances multiplied by the total current. That thing I want. So if I want to know now I1, what will be the formula for that? Yes.
R2 upon R1 plus R3.
No. It should match with whatever I say.
R1 plus R2 plus R3 into I.
I'll repeat. Aram se repeat.
R1 plus R1 upon R1 upon R1 plus R2 plus R3 into I.
R1 upon R1 plus R2 plus R3 into I. You mean to say this?
Yes, ma'am.
And that will be I1. But you are getting the same resistance over here, so wrong.
R2 should be there.
It should be R2.
Yes, ma'am.
Still it is wrong.
R3.
2 and R1.
So it should be R3 and still it is wrong.
R2 into R3.
2 and R1.
एक ही minute,
R2
one at
plus
a time.
R3.
One at a time. Daksh bolo.
R2 plus R3.
Daksh said R2 plus R3.
Yes, ma'am.
Wrong.
R2 into R3.
R2 into R3. Who said? Who said R2 into R3?
Gaurav.
Gaurav. Still it is wrong. Or
R1 into R2.
R1 into R2 is wrong. Again, listen. आप लोग सुनते नहीं हो and हमको तो सब पता है ना? Listen. हाँ, बोल ध्रुव बोल पहले.
No, ma'am.
No.
यही है.
ठीक है, यही है. अभी मैं बोल रही हूँ. I'm not telling you the answer. I want answer from you only. मैं तो answer बताऊंगी ही नहीं. मैं आपको फिर से the same thing I'm repeating. Listen carefully. When you want to calculate current through a particular resistance, that is equal to resistance in the another branch which is parallel to it divided by the addition of parallel resistances multiplied by total current entering the combination, parallel combination. Now think over it. Take 2 minutes. Why you are in a hurry to finish up with your task? है ना? 2 मिनट लो, सोचो और फिर मुझे बता. अभी इतने कॉन्फिडेंस से नो नीड मैडम टू चेक द आंसर. ऐसे होना चाहिए कि मेरा आंसर तो सही ही है. No one? Or should I wait?
Ma'am, R2 R3 upon R2 plus R3 upon R1 plus R2 plus R3.
रुक दर्शन फिर से बोल. हाँ, फिर मैं लिखती हूँ, तू बोल.
R2 R3 upon R2 plus R3 upon R1 plus R2 plus R3.
तूने ना, मैं तो बोलूं 70%. अरे रुक एक मिनट, रुक. कौन है? कौन था?
मैं.
दर्शन.
Yes, ma'am.
60% करेक्ट है, थोड़ा सा बचा है रॉन्ग है. क्या है वो? You are thinking right. Still you are not applying the full thing which I told you. Very correctly you did the first step. But the second step में तेरा wrong है. क्या wrong है दर्शन? अच्छा, any of you got what he did? क्या है ये? बाबा मुझे
हम
आंसर
पैरेलल कंडीशन लगा दें.
पैरेलल कंडीशन, राइट? ही इज सेइंग दैट R1 के पैरेलल में क्या है? यस, बिल्कुल सही। R2 पैरेलल विथ R3 है, ना सिर्फ R2 है ना सिर्फ R3 है, ना इंडिविजुअल है ना एडिशन है, इनका पैरेलल कॉम्बिनेशन इज इन पैरेलल विथ इट. So what he did, he is drawing now R2 parallel with R3. Then what mistake he made? What is his mistake?
मैम R2 R3 upon R2 plus R3 upon में R1 plus R2 R3 upon R2 plus R3
Very
है.
good, very good. ये R2 plus R3 absolutely correct now, है ना? Parallel combination divided by R1 plus the parallel combination multiplied by I. So if you simplify, this denominator will go and it will be R2 R3 upon, no need to do this thing, I'm just doing because it looks good, that's why, right? R1 R3 plus R2 R3 into I. Yes, all of you are with me. Understood? Yes or no?
Yes, ma'am. Understood.
Good. Chal. What about others? Only one understood.
Yes, ma'am. Understood.
Understood.
Okay, good. चलो, तो बस अभी पैरेलल कॉम्बिनेशन हमने कर लिया, हमने लॉ भी देख लिया. लेट मी सेव दिस एंड देन विल, अच्छा, आई कैन स्टार्ट न्यूमेरिकल ऑन दिस साइड ओनली, दैट इज बेटर. यही स्टार्ट करते हैं. The continuation में it will be there. So I'll give you one numerical. आपका मर्जी है आप कैसे सॉल्व करते हो. Is just DC, तो you can go by your Ohm's law, you can go by your just division of current, division of voltage, whatever you want, right? But if it is, I don't think IMA में इतना specific पूछेंगे, but फिर भी from my side I'm telling you, if the word will be used, solve it by current division rule, then you have to go by that. Solve it by voltage division rule, then you have to go by that. If nothing is mentioned, आपका मर्जी, आप जैसे सॉल्व करना है वैसे कर सकते हैं. ठीक है, चलो. और DC सर्किट, अच्छा मैं I should write now numerical 5. Yeah, a DC circuit formed of two resistors R1 of value 30 ohm and R2 of unknown value 'right, this thing. Then how R1 and R2 are connected? It's given R1 and R2 are connected in parallel. Yeah. Then what is the next thing? Together with resistor R3, together with R3 of value 6 ohm, connected in series. फालतू में complicated बना है. Connected in series with the parallel group. Okay, the potential difference across R3 is 84 volt. Okay. If the total power in the circuit is 4312 watt, calculate okay, I'll write on this side. Just a moment. Yeah, calculate number 1, value of R2, second one, the applied voltage, then the third thing, total applied voltage, and current in each resistor. Same thing we are going to do. I'll give you 5 minutes. 15 10 ko we'll talk about this. 2:30 ना 2:30 को स्टार्ट हुआ बाप रे मुझे लगा 2 बजे स्टार्ट हुआ एंड दिस इज 3:05 हो गए क्या हाँ तो 3:10 को we will discuss. Meanwhile, if you'll get any answer, please type in the chat box. Don't send it to everyone. Third thing is, first I want you to draw the diagram. सबसे पहले इलेक्ट्रिकल में जो भी डेटा दिया है बेस्ड ऑन दैट यू ट्राई टू ड्रॉ द डायग्राम. दैट विल बी 100% डायग्राम करेक्ट है ना 50% करेक्ट न्यूमेरिकल यू हैव ऑलरेडी सॉल्व्ड. आई एम टेलिंग. ओके चलो तो डायग्राम ड्रॉ करो एंड स्टार्ट सॉल्व. And if you want me to draw, I will also draw. You also draw it. I'll draw it after 1 or 2 minutes. Let me see how many of you start correctly and get the answer correctly. अरे कर रहे हो?
Yes, ma'am.
हाँ ठीक है ठीक है, करो. I will also draw the diagram. Meanwhile, उतना टाइम बचेगा अपना. R1 R2 parallel and in series with R3. Okay, I have written all the data on the whatever is required on the board. Okay. Chalo. Not a single answer yet. First basic answer तो दे दो. Current कितना है? Current in what? क्या था? नहीं, current नहीं. हाँ, current in each register. So current in R3.
$14, ma'am.
Correct. I said type in the chat box. Keep on typing in the chat. Correct है ध्रुव. Right. So go ahead. बाकी है क्या अभी? करना बाकी है अभी? Whatever answers you got, put in the chat box. So it will be easy for me to know what you did and whether it is correct or not. Yeah, right. Then total potential applied. Only one student has solved a what? बहुत ज्यादा टाइम लग रहा है नहीं? Keep on putting your answers in the chat box. Himanshu, Indrajit, Sahil. Because I want to know in by which method you are more comfortable to go for. इसलिए मैंने मेथड भी स्पेसिफाई नहीं किया. I want to know how you are solving, by which way you are going. So whenever you are typing your answers in the chat box, no, I'll come to know what is the flow. That's it. आप कर रहे हो या मैं कर दूं? अभी स्टार्ट करूं मैं लिखना? सॉल्यूशन दे दूं मैं, और शुड आई वेट?
मैम आप स्टार्ट कर दो.
ओके होना, ठीक है. ध्रुव आपने आगे सॉल्व किया नहीं? Okay. But next numerical onwards, I want you to solve, because this is not happening in other classes. They are solving.
मैम R2 की वैल्यू 34 पॉइंट कुछ 2 आ रही है.
R2 की वैल्यू
यस मैम पॉइंट में आ रही है.
आने दे. कितना है?
34.2.
Absolutely, दर्शन करेक्ट है. And individual currents, I1 and I2.
मैं वो निकाल रहा हूँ.
हाँ, I'll wait then. तो बोलो ना कि मैडम जरा वेट करो. और
मैम वो पॉइंट में आ रही थी ना, इसलिए मुझे लग रहा कि पॉइंट में तो आएगी नहीं.
रेजिस्टेंस क्यों नहीं आएगा? रेजिस्टेंस कैन बी इन पॉइंट्स, व्हाई नॉट? सी रेजिस्टेंस पे बैंड देखे ना आपने, वो टॉलरेंस के तो बैंड होते हैं ना, एक बैंड सेपरेट होता है. तो these 3 bands and then this adds to it plus minus 0.5 or plus minus 0.1. So it's possible, don't worry. Value of the resistance can be in points, don't worry.
I1 आ रहा है 6.45.
एक मिनट है. I1 is 6.45. Okay, and
एक मिनट में बस. I2 5.6.
नहीं रे, कुछ गलत किया फिर.
ओके मैम.
ये लास्ट आंसर तेरा रॉन्ग है, बाकी तो सारे आई फील करेक्ट है. Any other student want to say anything? Otherwise I'll start. दर्शन.
यस मैम.
ये दर्शन ही था क्या? मुझसे जो बात कर रहा था वो कौन था?
यस मैम.
हाँ, दर्शन. Okay, so your one answer is wrong, right?
यस मैम.
Okay, what about Kunar and others who said just wait for some time? Dhruv, what your answers are? Remaining answers?
मैम I तो 7.55 आ रहा है.
हाँ. Total I?
नो मैम टोटल तो 14 है.
Total 14 है, तो one of them is 7.55 and second one?
सेकंड 6.45 आ रहा है.
ठीक है, करेक्ट है. थोड़ा सा शिफ्टेड है, बट थोड़ा सा पॉइंट के बाद डेसिमल पॉइंट शिफ्टेड है, बट दैट इज
12.28.
नहीं रहे, कुछ तो मिस्टेक कर रहे हो. देख,
ओके.
now I'll solve. But good, you tried. That is the main thing. Very, very correct. So the first thing is, सबसे पहले if I look at the circuit, I know that voltage दिख रहा है, current दिख रहा है, voltage दिख रहा है, resistance दिख रहा है, तो current will calculate. One more thing, this current is going at this point, getting divided, again they will combine, right? At this point, so of course this current is I only. So the current which is going to pass through R3, no need to say I3, it is R3, it is I only. So first I would like to calculate I, and that is going to be 84 divided by 6. So your I is coming out to be 1414 ampere. This is the first step which fixes your current, main current, right? Then the next thing is one more thing. This is the current which is through the whole circuit, right? So through your battery also the current is 14 ampere. So let us calculate voltage because power is given to us. So the second point will be P is equal to V into I, right? P is 4312. V we don't know and I we know 14. So V will be equal to how much it is coming out to be? कर दो जरा मेरे लिए 4312 divided by 14. How much it is coming out to be?
308.
308 volt. Very correct. Right. Now 308. See, these two things are this parallel combination and this combination is in series. Right. So if I'll name this potential as V or kahi V nahi mention V. यहाँ पे I mentioned. So see, I'll mention it as V dash. Right. So very well I can calculate V dash also. And I'll be able to write V dash is equal to 308 total minus 84. So which will come out to be 22 and 4, 224 volt. Correct. तो combination का दोनों resistances के across कितना potential होना है we have calculated. Now the next thing is we want to know the this value of R2, and we know that current which is going right for this combination. If I'll write it as V dash total potential, total current, then equivalent resistance will be R1 into R2 upon R1 plus R2. Correct. So now let us one of the resistance we are aware of and other also all values we know. So it is going to be 224 into 14 into R1 is 30. So 30 R2 divided by 30 plus R2. है ना? तो इससे पहले तो divide कर लेते हैं. V is equal to IR. So how much it is coming? 224. I think 16. So correct, 16. 16 into this 30 plus R2 is equal to 30 R. So it is going to be 480 plus 16 R2 is equal to 30 R2. So 16 का मतलब है 14. 14 R2 is equal to 480. And that's why your answer was coming in points, right?
Yes, ma'am.
Yeah. Okay, let me rub this thing first. Yeah. So R2 is coming out to be 34.286. Yeah, right. This part we did. So we calculated value of R2. Then we calculate what else was asked. Value of R2 done. Total potential applied done. Now current in each resistor, simple. Now voltage is there, right? You know the resistance values. Finish it off. So we can write it as I1 is equal to potential how much? 224 by 30. कितना आ रहा है ये वैल्यू?
7.46.
Yeah, 7.467. So someone got no 4. Yeah, kuch 8. I don't know. I slightly it was shifted ampere. No? Sorry. And I2 will be I minus I1. Total I minus I1. Total I is 14. 14 minus 7.467 will come out to be equal to 6.533. Now, a number of ways are there. If you don't want to go by potential, you can divide the current also. Current division से भी कर सकते हो. आपकी मर्जी, आपको जैसे करना है. Any of you, any doubt in this particular numerical? Yes. Is it okay? Is it okay?
Yes, ma'am.
Okay. चलो तो आई क्लियर दिस. क्लियर कर दो बोर्ड.
Yes, ma'am.
Okay. And we'll go for attendance now. Next lecture में और थोड़े numerical करेंगे. And then we'll go for sources and all those things. Okay, and some more theorems. तो अभिषेक किया there. अभिषेक बेड़गांवकर सोया है. अभिषेक
Yes,
हाँ ना?
ma'am.
हाँ तो सोया
ma'am.
है. हाँ सोया है. वो बोल रहा है यस मैम मैं सोया. ओके. रौनक. भारत.
Yes, ma'am.
भुवन.
Present, ma'am.
कृष्णा. नहीं सॉरी चैतन्य. 46.
Present, ma'am.
देन दक्ष.
Present, ma'am.
दर्शन है. देव.
Present, ma'am.
या 53 देव.
Present, ma'am.
देवांश.
Present, ma'am.
55 देवांश. 55 देवांश.
Present, ma'am.
ओके. तो कौन बोल रहा है 53?
Ma'am, he is with me. He is with me.
Why? But if your things are working now, net and all, why you are sitting together?
I'm roommates, ma'am.
अरे तो क्या हुआ? मेरे अटेंडेंस के लिए प्रॉब्लम आएगी ना. समझ ले कि कुछ प्रॉब्लम हुआ एंड
He has joined, ma'am. He has joined. There is a...
so he should give the attendance. Simple. देवांश है क्या? सोया है. उसको जगा तू पहले. देव
जागा में मैम. ये देवांश ही बोल रहा था अभी.
पक्का ना? हाँ ठीक है. देवीश 56.
Present, ma'am.
देव.
Present, ma'am.
या ध्रुवो.
Present, ma'am.
ध्रुव है. कौन सा ध्रुव है? ध्रुव त्यागी होता है. ध्रुव काकड़े 88. ये कभी अटेंडेंस देता नहीं. यस यार प्लीज उसको
Yes,
थोड़ा.
ma'am.
हाँ
मैम काकड़े सो रहा है.
काकड़े सो रहा है मुझे पता है क्योंकि वो लास्ट लेक्चर में भी सोया था और शायद उसके पहले लेक्चर. बिकॉज मेरे ब्रेन में ना धीरे धीरे नाम सारे पक्के होने लगते हैं.
Yes,
और जो
मैम. मैम मैं ध्रुव त्यागी हूँ. कहीं मेरा नाम डाल लो.
मुझे पता है ध्रुव. मैं वो सरनेम भी देखती हूँ. डोंट वरी. ओके. तो काकड़े एब्सेंट है. निशांत.
Yes, ma'am.
अनिमेश है. गौरव.
Present, ma'am.
हाँ गौरव भी है. हर्ष भी है. हर्ष ने आंसर दिया था.
मैम आई एम प्रेजेंट एक्चुअली. ध्रुव काकड़े मैम.
अच्छा तो व्हाट यू आर डूइंग ध्रुव?
मैम पानी पी रहा था.
झूठ मत बोल.
सच्ची में मैम.
एक मिनट फोन आ रहा है. हाँ बोला. नाही तुम्ही ते सांगणार होते ना पे करायचं.
Present, ma'am.
Present, ma'am. Ma'am, Harsh Yadav present.
मैम आपकी आवाज नहीं आ रही. माइक म्यूट है आपका.
Ma'am, you are not audible.
Ma'am, you are not audible.
Now can you hear me? Sorry मैंने माइक बंद
Yes,
किया.
ma'am.
Oh,
Yes, ma'am.
okay. So I said Harsh Yadav.
Yes, ma'am. Present, ma'am.
Okay. Manthan. Manthan, you are there.
मैम एक्चुअली मंथन आते डिवीजन 4 के साथ प्रैक्टिकल परफॉर्म कर रहा है.
क्यों?
क्योंकि मैम वो लेट रिपोर्ट किया था ना तो उसका और हमारा प्रैक्टिकल साथ नहीं हो रहा. वो डिवीजन 4 के साथ है वर्कशॉप में.
Okay. पर क्या करें अभी? I have to mark him absent and I'll put the thing performing.
मैम वो डिवीजन 4 के साथ ही सुबह लेक्चर अटेंड करता है. मतलब जो सुबह लेक्चर्स होते हैं डिवीजन 4, 5, 6 के साथ.
हाँ
उसी के साथ वो लेक्चर अटेंड करता है. 2 के साथ अटेंड करने से
तो क्या मैं अटेंडेंस
मतलब उसका मैट्रिक्स ही ईयर कोऑर्डिनेट में 4 के साथ.
हाँ तो उसको 4 में ही बिठा देते हैं. डिवीजन ही चेंज कर दो ना उसका. ठीक है. Prathamesh, I got what you are saying. Let me talk with your coordinator and then we'll think of. Okay. Yeah. Himanshu hai, Hunar hai, Indrajit hai, Indrayan, Prathamesh hai, Jeffy. If you are there,
Present, ma'am.
okay. कौन present बोला अभी?
Ma'am, 77, Indrayan.
Okay. Jeffy, I said 79. Okay. Jagtap. Sorry, Sahil.
Present, ma'am.
Yeah. Then again Sahil Jagtap.
Present, ma'am.
Okay. Then Sanket.
Present, ma'am.
Jatin.
Present, ma'am.
Jatin.
Present, ma'am.
Yeah, okay. Jitesh
Present, ma'am.
and Prasad.
Present, ma'am.
Chalo. I'll save. I'm having one more lecture, so I'll stop sharing. All the best, everyone.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. Jai Hind, ma'am.
Jai Hind, Jai Hind.